Welcome to Mrs. Gray's Geometry videos. Today we're going to start lesson 6.6 and we are going to look at three more special quadrilaterals. The first one that we are going to look at is a trapezoid, and there are only a few things to know about a trapezoid. This is a perfect example of a trapezoid. The first one I want to clarify is that it is not a parallelogram. The other special quadrilaterals that we looked at, the square and the rectangle rhombus, they are all parallelograms. The trapezoid only has one pair of parallel sides, where the other quadrilaterals that we looked at had two pairs of parallel sides. So I just want to clarify that first. So this is a perfect example of our parallel sides, and the parallel sides have a specific name, and it's called a base. So the two that are parallel, we always call those bases, and the other two sides are always called legs. And this is another example of a trapezoid. So there's not a lot to remember about a trapezoid, but the isosceles trapezoid has quite a few more properties. So the first one is, again, I'm just clarifying that it's not a parallelogram. It only has one pair of parallel sides, and again, the other shapes that we looked at, they were parallelograms. So this side would be parallel to this side, and again, those are called bases. And specifically with an isosceles trapezoid, the legs are always congruent. And as you can see from the diagram, the base angles are also congruent. Now in the picture I did not show the markings for the top base angles, but these are congruent as well. They were just really hard for me to add into this PowerPoint. So just remember, if you're doing a diagram at home, to show that these base angles are congruent and these two top base angles are congruent as well. And the diagonals are congruent. So that means that this diagonal right here is going to have the exact same measurement as this diagonal here. And just to clarify that these diagonals do not bisect each other from this point of intersection, and you can clearly see it if you draw it out. So if you're ever unsure, just draw it out, and again, it should jump right out at you. So this one right here is clearly a lot smaller than this segment over here. So the diagonals in measurement are congruent, but they don't bisect each other. Now we're going to look at the kite. With the kite, the diagonals are perpendicular. And again, if you're making a note card, make sure that you make a note of this. This is going to be really important when we find our missing angles. We're always going to add in this 90 degrees here, and we are getting ready to do the Pythagorean theorem, which we are going to do in a lot of our chapters coming up. So again, these diagonals right here always form 90 degrees. They have one pair of opposite angles that are congruent. So I have this angle highlighted in orange, this highlighted in orange as well. But there's only one pair. And remember, in the parallelogram, we had two pairs of opposite angles that are congruent. So that makes the kite a little bit different. So this one here and this one here, these are congruent. And again, if you draw it out, that should be pretty clear to you. And then the last one is that we have two pairs of consecutive congruent sides. And you can see that in the diagram. And consecutive means right next to each other. So this side, or this segment, is congruent to this segment. And then over here, this segment is right next to this segment. That's what we mean by consecutive. So this is congruent to this. Now we are going to take what we have learned and apply it. But before we begin, we need to learn one more thing, and that is the trapezoid midsegment theorem. The midsegment of a trapezoid is specifically if you were to take the midpoint of a leg, and we know it's the midpoint because we see these congruent marks right here, and connect it to the midpoint of the other leg. And again, we know that it's the midpoint because we see these congruent marks here, that this is the midsegment of the trapezoid. And the formula that we're going to use is that the trapezoid midsegment is always 1/2 of the base 1 plus the base 2. So we are just basically taking an average of the bases. We're adding them together and dividing them by 2. And it doesn't matter which one we label as 1 or 2. We just have to distinguish that we have one base and that the other base has a different measurement. And to apply this, this is specifically number 15 on your homework. We're going to put some numbers and variables into this formula. So we've been given that the midsegment is 2x plus 1. So instead of this trapezoid midsegment right here, I'm going to replace it with 2x plus 1. And it equals 1/2 base 1 plus base 2. So instead of the b, I'm going to substitute it and put in x minus 1. Instead of the b2 of the formula, I'm going to substitute that and put 15. So I have taken what I've been given here and plugged it into the formula. Now I just need to do a little bit of basic algebra. The first thing I'm going to do is just combine or simplify. 15 minus 1 is 14. And then the next step is I like to get rid of my fractions. So what I'm going to do is I'm going to multiply both sides by 2. That's what I'm showing you here in blue, because that allows me to cross out this denominator and this numerator. That just makes things a little bit easier. And now I need to distribute. So 2 times 2x is 4x, 2 times 1 is 2. I have crossed out this 2 and this 1/2, and I'm just left with the x plus 14. And then moving over here, just doing again some basic algebra, I have subtracted x to get 3x, I have subtracted 2 to get 12, and then just divide both sides by 3, my x equals 4. Perfect example of how you're going to use the the trapezoid mid-segment. Just plug everything right into the formula and then solve for x. And then if it were to ask you for the actual length, then you would just plug x back in. Let's take a look at another problem. This is number 23 of your homework. This is a kite, and we learned specifically that the diagonals are perpendicular on a kite, which means that all of these angles here are going to be 90 degrees. Now, in a kite, whatever this angle measurement is here, it's the same measurement right here. So I'm going to fill this in. I'm just filling in everything based on those basic properties that I've learned. So if this is 46, this is going to be 46. I have pre-filled in everything that's basically my given information. Now I'm going to take a look at this triangle right here. I know that all three angles add up to 180 degrees, so if I just subtract these two, it's going to give me this angle right here. I've done that right here. So I've subtracted the 90 and 34. That would leave me with 56. So now I have figured out this angle, and this angle is always going to be congruent to this angle right here. Now I can do the same thing for this one. 180 minus the 90, and I've shown this right here, minus 90 minus the 46 is 44 degrees. So this angle is 44 degrees, and this angle here is 44 degrees. So what I've done is I've just taken what I've learned about a kite, filled in as much as I could, and then just used the fact that the angles in a triangle add up to 180 degrees. We're going to do one more problem, which is what I consider the challenge problem. This is 35 on your homework. We have two different variables, which makes this a little more challenging. Now, this is definitely a kite because we have two pairs of consecutive congruent sides, and we learned previously that in a kite, opposite angles are congruent. And I'm going to start with the fact that the opposite angles are congruent to set up an equation because I have an x here and an x here. So that seems like the logical place to start. So what I've done here is I've just taken this angle, and then I've made it congruent to this angle here and just use my basic algebra. 4x minus 3x gives me x, add 30, x equals 35. Now we need to take a step back because this clearly looks like it's a little more challenging. What are we going to do? We have two different variables. Well, remember from the last slide that this angle right here is always congruent to this angle. So now I have three different angle measurements. The only tricky part is that I have two different variables. Well, I have solved for x, so I am just going to plug it into this right here. My x equals 35, so I've just rewritten this, but instead of x, I've put 35. Now I know that this angle right here is 110 degrees. Now I have enough information because I only have the y to solve for. So I'm going to replace this 4x minus 30 with the 110 and set up an equation and use the fact that all three angles in a triangle add up to 180. I need to move this over here. So what I've done is y over here. This I'm going to use the 110 plus 110 plus this right here, 2y minus 20 equals 180, and solve for y. So combining any like terms, y plus 2y is 3y, subtract 20 to get 90. I've simplified or combined any like terms, and now I'm going to subtract 90 from the 180 and then divide by 3. Y equals 30. And I just, again, had to just take a step back and used what I've learned about the kite to solve for both variables.